Electric vehicle chargers currently come in three different models: Level 1, Level 2, and Level 3. Level 3 is also commonly known as Direct Current Fast Charging (DCFC). In Level 1 and 2, the electric vehicle is connected to AC power, 120 volt or 240 volt, and a battery charger in the electric vehicle converts the AC power to the DC needed to charge the battery and controls the charging process. In DCFC, the DCFC converts the AC power to DC, and the DC power is sent directly to the electric vehicle battery bypassing the onboard battery charger. This allows the DCFC to charge the electric battery directly. Level 1 and Level 2 charging is generally limited by the AC power available and the size of the onboard battery charger installed in the electric vehicle. DCFC is limited by the rating of the DCFC equipment and the amount of power available from the utility or other primary power sources. The charge rate, range of electric vehicle, and amount of time that the electric vehicle is available to recharge, known as dwell time, work together to determine the best type of electric vehicle charging system. Electric vehicle charge.
The battery management system, or BMS, is a crucial component of an electric vehicle. Its job is to manage the battery's health, performance, and safety. The BMS continuously monitors the battery state of charge, temperature, and voltage to ensure the optimal performance. It also protects the battery from overcharging, over-discharging, and overheating, which can reduce its lifespan and pose a safety hazard for the driver and its passengers. In addition, the BMS controls the charging, discharging of the battery to prevent damage and maximizing the efficiency of the batteries. The BMS also communicates with the vehicle onboard computer, providing information on the battery status, remaining charge, and estimating time to recharge. This information is crucial for the driver to plan their journey and avoid running out of charge. Overall, the battery management system plays a crucial role in ensuring the safe and efficiency and reliability of the vehicle's battery and itself.
Conductor or electric conductor is a substance or material that allows electricity to flow through it. In a conductor, electric charge carriers, usually electrons or ions, move easily from atom to atom when voltage is applied. There is another part called inverter. Inverter is a device that can convert DC power to the AC power used in electric vehicle motor. The inverter can change the speed at which the motor rotates by adjusting the frequency of the alternating current. The inverter is a critical component in an electric vehicle's powertrain. The inverter receives signals from the vehicle's control system that tells it how much power to deliver to the motor. The inverter uses components such as transistor, capacitor, and diodes to convert the DC power from the battery into AC power that is suitable for driving the electric motors. The AC power produced by the inverter is then delivered to the electric motor. The electric motor uses AC power to create a rotating magnetic field which interacts with the permanent magnet on its rotor. As the vehicle accelerates or deaccelerates, the control system sends signal to the inverter to adjust the frequency or amplitude of the AC power it produces, which in turn controls the speed and torque of the motor. Overall, the inverter and the motor work together as part of the electric vehicle's powertrain to convert electric energy from the battery into mechanical energy that drives the wheel on the vehicles. The precise operation of the inverter and the motor will depend on the specific design of the vehicle.
There are three components: motor, inverter, and vehicle control unit that ensure the transmission process from motor to wheel. Motor is responsible for converting electrical energy into mechanical energy to power the vehicle. The inverter is a device that converts the DC power into AC power that can be used by the motor. And VCU, or vehicle control unit, that is the brain of the vehicle, controlling and coordinating the operation of the motor and inverter. When the driver presses the accelerator pedal, the VCU receives a signal and determines how much power is needed from the motor to achieve the desired speed. Then the VCU sends a signal to the inverter to convert the DC power into AC power at the appropriate frequency and voltage for the motor. Then the inverter sends this power to the motor, which uses it to turn the wheels and propel the vehicle forward. There are three components.
Braking turns car's kinetic energy into electricity to charge its battery and boost efficiency. The electric motor in electric vehicle runs in two directions, one to drive the wheel and move the car and the other to recharge the battery. When you lift your foot off the accelerator pedal and onto the brake, the motor swaps direction and starts to put energy back. As you slow the speed of an electric vehicle, re-energetic braking engages the motion of the wheels to act as a sort of crankshaft, sending energy to the motor via rotation of motor shaft. This transfers of energy from the wheels to motor slows the vehicle down, often rapidly, and this is why EV owners refer to one-pedal driving, as they rarely use the brake pedal. The rotation that is applied from wheels to motor opposes the movement of the motor shaft and creates a counter electromotive force or back EMF. In short, the reverse force on your motor's magnet converts rotational energy in electrical energy. If we put this in simply scenario, the EV motor essentially serves the roles of a generator powered by a crankshaft, while regenerative brakes harvesting power that is stored in the battery for later use. Moreover, the progress that electric vehicle industry has shown in recent years is not only extremely welcomed but highly necessary in light of the increasing global greenhouse gas levels. The realization and success of this industry relies heavily on the global population, and it is our hope that through mass marketing and environmental education program, people will feel incentivized and empowered to drive an electric powered vehicle. Each person can make a difference, so go electric and help make a difference.